right, moving on to a new topic, but still with our three-dimensional figures. We're going to start volume. This is actually back in our textbook now. This is 11.2. We are going to be doing volume of all of our shapes. And remember, volume is how much something can hold. The amount of material you can put inside of something, like a pop can or a room, if you filled it up, or a box. So volume is defined as the number, with that M, the number of cubic units an object can hold. So we will start with the volume of a prism. So if we were to look at, say, a triangular prism, remember we got our two polygon bases. Big B, and then we got our height. The volume is very easy. It's just the area of the base multiplied by the height of the prism, not the height of the triangle. So remember, we could talk height of the triangle here, but this height over here is the height of the prism, how far apart those bases are. So it's big B times H is your volume. So volume, maybe we'll put that over here, big B is big B times H. So we will do a couple. Let's start simple. So, I tried to draw a square prism laying on its side. So these are the bases here and here. So this is a square. We're going to go 4 by 4 square. And we're going with a height of, let's go 9. And all we're finding this time is volume. So we're not doing double problems. So volume is big B times H. The base, remember, is this square. The base, to get the area of a square, is 4 times 4. And then the height of the prism is the 9. It's how far apart those are. It's not this 4 up, it's how far apart those are. So we're going to get 16 times 9, which I can't do in my head. 144. Okay, let's try this one. A new shape for us. We haven't done one of these in a while. Count the sides there. I did not draw a hexagon. We do a lot of hexagons, but not this time. Alright, let's go 8 on a side. And let's go 7 here. Remember, these are all regular, so all of these sides are 8. Alright, so we have a pentagonal prism. That's 1, 2, 3, 5 sides. That's a pentagon. So, the volume being big B times H, that pentagon, we have to use that regular polygon formula, 1/2 AP. So, I'm going to write that in so I can keep my eye on the prize. And then times the height of the prism. This one's easy, that's the 7. The apothem and the perimeter, that's a little bit of work. Perimeter isn't going to be bad. I have 5 sides of 8. So the perimeter would be 40. the apothem is going to take some trig. There's the apothem. Here's the right triangle I'm going to work with. That's going to be a 4. I need an angle here so I can do some SOHCAHTOA. Well, we're going to take 360, divide that into 5 triangles. That's 72 degrees, but then I got to cut that in half to get each side of this. 36 degrees. So, now back to SOHCAHTOA. We've got opposite and adjacent, that's tan. So the tan of 36 degrees, opposite is the 4. The apothem, we don't know. Doing cross products, 4 gets multiplied by 1. Divide by the tan of 36. .51. So the apothem is coming out 5.51. Kind of ran out of room there. That's a 5.51. Okay, now we're ready. 1/2 times 5.51. Perimeter was 40. Height is 7. One half times 5.51 times 40 times 7. What's coming next? Let's go volume of a cylinder. Okay. A cylinder is very much like a prism. It's the area of the base times the height. That's terrible. Cylinder. You can think of it as a prism. But the base on a cylinder is always a circle, so we can replace big B with pi r squared. So the volume of a cylinder, filling that in, pi r squared h. Let's try a couple here. What did we have? 2, 3. Let's go with an oblique. We haven't had anything oblique, so it's got a big lean to it. Here's what I know. The circumference of this thing is 14 pi. The height from top to bottom would have to be given over here. We're going to go 6. Your goal is to find the volume. The volume of a cylinder, pi r squared h. I gave you the height over here, 6. Our goal is to get that radius, and the radius is hidden inside of the circumference. So we got to work backwards. Remember, circumference is pi times diameter. So if I set up a little equation where I substitute in the 14 pi here, I'll be able to solve for diameter and then get the radius. So, off to the side, I'll go here. Circumference equals pi times diameter. We've got the circumference being 14 pi. I can divide by pi and see that the diameter is 14, which gives us a radius of 7. Cut it in half. And now it's super easy. Pi, so my radius is 7. Height is 6. So 49 times 6. You can multiply the pi in. I'm not going to. I'm just going to carry it along. 294 pi. Try another tricky one. Cylinder again. 12 for a height. That area is 36 pi. Square inches in there. Okay, your goal is to find volume. Well, you can be clever here. Remember, this pi r squared, even though I didn't give you the radius, you really don't need it, because this pi r squared is the area of the base. I gave you that right here, 36 pi. So I can take this pi r squared, throw it away, and substitute in 36 pi. And multiply by that height of 12. Or 32 pi. Okay, now let's do some composite figures. Here's where the work comes in. Those are the basic ones. Now some challenge for you. Number 5. Find volume of composite figure. Okay, here's our composite figure. We've got a cylinder. But then we've got a square hole drilled through it. So this is an opening in it. Okay, so see like a pop can, solid pop, well maybe not a pop can, no it would be solid, a cement cylinder, and then you've got this hole drilled out of it for this, a peg to fit in there. So if we want to find the volume of this remaining figure, so our plan, the volume of this composite figure would be, we would have to find the volume of the solid cylinder, and then we're going to subtract off that hole that's in there, because that volume is missing. So minus the volume, and that would be a square prism. So that's our plan of attack, the cylinder minus that opening. I'm going to go for formulas, then I'll give you values. So looking on the card, the volume of the cylinder, pi r squared h. The prism, where, there you are, big BH. Okay, so now some values for you. We've got a square, 2 by 2. From the center of this to the circle is going to be 4. So we've got a radius of 4. And then the cylinder is 3 tall. So this first formula is focused on the cylinder. We need the radius, which is 4. The height would be 3, it's just laying on its side. The part that's missing, the base of this prism, is a square, so that's 2 times 2. And the height of that opening is going to be the same as the cylinder. It goes all the way through. So 16 times 3, I'll go times pi. Let's see, that's going to round up, 80. And that'll be 12. Subtract 12. .80. And if we tried that one more, yep, we got time for one more. Let's take a look at this house. Alright, here's what we got. 11, 5, an 8, 8, 8 equilateral triangle. And yeah, I think we got regular we'll go 5 here also. 5 by 5. Okay. So our goal is to find volume of this composite figure. This one might be a little bit easier for you to see. I see two shapes here. I see a triangular prism laying on its side. And underneath it, I see a square prism. Those are my two squares laying on its side. So we have two prisms, and we're going to be adding them together because we don't take anything away. We just added the two shapes together. We can fill them both up. So prism is big B times H plus big B times H. This time, big B, because it's the triangular prism, it's the area of a triangle, that'll be BH divided by 2 times by height of the prism. Remember, these two H's do not apply to the same thing. This is the triangle height, this is the prism height. The square prism, we've got base times height, and then the height of the prism. Alright, so let's go back and see if I gave you everything. Focused on the triangle. Got the base is 8, or excuse me, well that's not a 5 then, is it? Duh. Gotta match that. This is 8 by 5, so it's not a square. It's a rectangular prism. Look at me. Mistake. This is my last one too. I almost made it. So rectangular prism, not square. So back to this. So the base of the triangle is 8. Height is missing. We got a 4. We'll have to do a little Pythagorean theorem. So I'll do that off to the side here. 4 squared, H squared equals 8 squared. So 64, subtract 16, square root, 6.93. Eight times 6.93 divided by 2. Now this H is the height of that triangular prism. How far apart are those triangles? 11. Now I'm onto the rectangular prism. The base and height of the rectangle are 8 by 5. The height of the prism, again, how far apart are those rectangles? 11. And now it's all calculator work. So 8 multiplied by 6.93 divided by 2 times 11 plus, let's see, that's 40 times 11, 744.92. There we go. Not bad. And we're going to stop there.